Hello everyone, my name is George Bentinck. I'm the product manager for cameras at Meraki. I'm going to be going through like a load of stuff super fast, but that means you need to stop me at any time. You want a little more detail, you want a question answered. We've got demos, we've got some real physical things in front of you to play with. I'm going to give you a little bit of a backstory as to where we are with the camera and what it's going to be doing in the coming months and years. So I want to tell you a story, like how I started out with this, and I love this slide because no one really expects a unicorn on the first slide, especially because I use this in my executive briefings for all executives that come through the Meraki office. This was literally the thing on the top of the official sign-off document when the camera was born. And this was put there by the two engineers that wanted to work on it, and it was signed off by Todd, who's the SVP GM of Meraki. And I was incredibly surprised when I saw it, because I wasn't expecting it, but I thought it was a really great statement of intent around making something pretty magical, something pretty simple, something that embodies the Meraki experience. Plus it has this other fun symbolism of the Bay Area with the sort of unicorn startup, some incredibly successful, highly valued company. And when I think of all of these things, and I think of cameras, I think of these. Any of you have one of these?
Yes.
A few people, okay. So the Nest Cam, previously the Drop Cam, sort of changed how we looked at security cameras at home. Really simple, really easy to use, Wi-Fi, cloud stored, plugged it in via USB, and really sort of aspirational for me when I look at making a really simple and easy to use camera. But Cisco doesn't have those consumer customers buying Nest Cams. We have enterprise customers, and their painful reality is much, much worse. This is not an image I've stolen from Google Image Search. I found this camera in the real world. This is in the town of Shasta, Northern California, in a bookshop. And I find it's like a really fun representation of just really how archaic that sort of technology is that people are using today. I think other than the intimidation factor of if it fell off the wall and hit you, it'd definitely kill you, it's not really providing a lot of security. But if we sort of stop joking and we look at the industry as a whole and get serious for a minute, it's really, really complicated. There are lots of things. This is one of the largest security trade shows in Europe. This is IFSEC. This particular set of images is from IFSEC 2015, and there are cameras everywhere. And there's vendors I've heard of, such as Bosch, for example, and then vendors I'd not really heard of before, like RaySharp and Tiandi, and vendors I'd never seen and will probably never see again. But they all look very similar, and they all have cameras that seem to have the same specs, same features, and all the other things that cameras seem to have. The other thing that everyone has are these beautiful boxes. So these are our good friends with their large box here, because you have all of this data. You have all of this video. It's incredibly rich, big data, and you have to store it somewhere. So if we take these things and we build a beautiful diagram, you end up with something that looks sort of like this. And this is a typical system for the lucky, modern customer with an IP camera network system, where they have their cameras with an Ethernet port connected to the network, and then you have your network video recorder, your NVR, or you have your VMS, your video management system, trying to manage and control all of this. But when researching for the development of the camera and building out this platform, absolutely no customer had anything good to say about the boxes. The hard disks fail, power supplies fail, RAID arrays get corrupted, they don't scale, they're super insecure because no one ever patches them. Not a single good thing to say. So when I try and think about it, it's like, why do customers buy cameras? In fact, this is an exercise I normally ask new employees at Meraki, like, why do customers buy cameras? And they say security, or safety, or like insurance. But actually, when you start trying to piece together all of these in a very abstract way, it's this idea of information. Like, customers are after information to answer a problem. And typically, because this technology has evolved from security as a use case, that's all it can really do. But if you get rid of all these boxes, which no one ever wants, what else can you use the cameras for? Can the camera become something else? Can that source of information do something else? Now the thing is, when I look at this, and then I look at this, again, beautiful diagram, and we look at all of the wireless LAN controllers that Meraki has been sort of making irrelevant or redundant over the last decade, essentially, we have a great deal of experience in building enterprise-grade, carrier-grade wireless networks with no boxes. The problem is, these boxes just need to move data around. They don't need to store it. And so if we're thinking about how do we eliminate all these boxes that customers really hate, and how do we go and do it for cameras, well, the obvious answer is to think of the Nest Cam and to think about building a cloud-stored camera. Because we're a cloud business unit of Cisco, this seems like the way to go. the thing is, one of the really strong customer verticals for us and for cameras is retailers. And they have tens or hundreds of thousands, or in some cases, some of our customers have millions of cameras, and yet they have like a T1. So they really need bigger pipes if they're going to have any chance of going to use a cloud-managed camera, and they just don't have them.
What's the bandwidth on?
On this particular one, I think this is about 1.8 men a second. Never been asked that one. I just went with it.
It's a new metric, yeah.
So why don't we just make the existing thing a whole lot better? Why don't we build a better box? Why don't we just make a cloud-managed NVR? Let's just make that a whole lot better. And it gets rid of some of the management problems, but how do you scale it? What if you only have one camera? What if you have 1,000 cameras? What if you need a hard disk that stores like a crazy amount or no amount at all? It's never going to work. And so what we did is think about this in a different way. And this is sort of like a product philosophy that we have at Meraki, which is this idea of focusing on solving problems and not building features. And you may have heard me talk about this before. And it sounds incredibly obvious. And it sounds like everyone should be doing this. And yet, time and time again, I see people not doing it. Have I asked any of you in the past if you've bought a TV? Oh, fantastic. Another group I can test this on. Hopefully, I don't go horribly wrong. How many of you bought a TV in the last 5 years? Okay. I mean, a tech audience, so I'm like onto a good grounding here. How many of you have a TV that has in some way the capability to do 3D? How often have you used the 3D on your TV?
When I bought it, just to see if it worked.
This is a recurring theme when I ask this question, is that just people have not used it. They used it once. Well, my favorite one was someone who got their TV into 3D mode and spent 2 hours trying to get it out of 3D mode, where not only was it a feature that wasn't useful, it actually a negative feature that made the TV like a bad experience.
There isn't enough glasses for everybody. So.
Yeah, and for poor people like me, you have to wear 2 pairs. It's just like not a thing. But you go out there and there's a TV for $1,000 with 3D and a TV for $1,000 without 3D. It seems like a good idea to get the one with more features because it's better value. But it didn't really solve those problems you had at home. And so why don't we take the things that Meraki is good at? So that's things like our expertise in cloud, our expertise in embedded and distributed computing systems, and focus on the user experience design as a primary thing of value, and go build a whole new camera system. And so last time I met you, we'd launched the camera, and we were just talking about the next generation of cameras. And since then, we now have a family of smart cameras. And so we have the MV22, the MV72, and the MV12. And you all have an MV12 in the larger of the boxes that are on the table or on the floor next to you. It is really pretty small, but it's incredibly powerful. I'm going to go through all the cool stuff that it does. But essentially, the architecture for the camera is you have a camera and a Meraki license and nothing else. No servers. We don't put video in the cloud. Everything is done in camera because the camera is built off the latest generation of mobile phone technology. And so that means we could put a huge amount of solid-state storage, 256 gig, and a whole load of other smarts which we're going to go through in the device, so you can have 100,000, and it doesn't matter. And so the camera has really turned into this incredible thing, because when you just need a camera and a Meraki license and power, you can use it for lots of stuff that people hadn't even thought of. So an example is a restaurant chain in New York that puts them in their kitchens so that they can observe what the chefs are doing for quality control of new recipes. So the head chef looks at it from the head office. You couldn't just put one on your desk and the moment it gets power, it's recording. In fact, this is a problem in the Meraki office because you're troubleshooting and you just plug in the camera and it's immediately recording your colleague and their keyboard and everything else. So you actually have to sort of like think more about the camera because it works sort of by default with just power. Now, I did bring one of the slightly larger ones. So the slight difference is you get here, in the same way that you have like a portfolio of access points, we're growing a portfolio of cameras. It's typically around the optical components within the camera. So the MV12 you have is a compact, fixed focal length camera. So it's got a really wide field of view. It's 114 degrees horizontal field of view. So you can stick it in a corner of a room and get like a huge view. They're great in retail environments and other places where you want something small and like unobtrusive. But then if you want a camera that can see further, then we have the MV22 and 72. This is the 22. It's got a varifocal lens, so you can zoom it in and get greater reach. A very small, interesting aside for you when you come to do it. I'll pass this around, but if I just pull this, it's a very satisfying pop sound. There's actually a huge amount of work that went into this, intriguingly. Typically, security cameras have this like plastic film or shrink wrap on the top, and it looks really ugly. And the Meraki hardware engineering team just did not want to do that. They wanted the camera to look really nice. They spent a year on the mechanical engineering to make it look nice, and they didn't want your first experience to be of that horrible plastic. So they spent a long time making this. And the secret is this is airtight, so it sucks on when it's on. And when you first put it off, it makes a very satisfying whoop noise. And that means you get a good out-of-boxing experience. And also, when you're sort of manipulating the camera, you don't get the lens all greasy and all dirty. So a small little aside on some of the attention to detail our engineering team like on the hardware parts. So how does it work? Well, the camera's always recording, and how long it can record depends on how you configure it, which we'll go through. I'm going to do some of that in the live demo. All the camera puts on the network is the configuration information, thumbnails, and metadata that we store in the cloud. And the design limit for this is 50K a sec, but it can be much, much lower. In fact, most cameras are around 10 or less, and very quiet cameras, and that's cameras that don't see a lot of people, a lot of movement, a lot of activity, it's like 2 or 3 kilobits per second. So really, really low. What that means, you could do some super cool things where you can deploy the camera sort of anywhere there is 3G or 4G, because the camera doesn't use your bandwidth unless you need it. So I run many cameras that are on very strange connections. So one of them is 7 cameras to a MS220 switch, to MR74, to an MR32 mesh bridge, to an MX, to a cellular gateway in the UK, and I can watch it from here. And I only use the bandwidth when I want to watch the video, which is really, really useful. The other thing is what happens if you're trying to get video and you're remote. And this is one of those really unique moments where you get better security that makes something simpler to use, because that's just something that doesn't seem to go hand in hand most of the time. So you load your Meraki dashboard, and when you ask for video, we check to see if there's an IP route between you and the camera. If there is, then we stream the video from the camera to you. If there isn't, then we create a proxy connection through the cloud, and then we'll get you the video anywhere in the world without VPN, and all of this is over HTTPS.
So local's local, not proxied out then. That's
correct. Yeah.
Fantastic.
So if you've got an IP route, it doesn't need to be layer 2, just needs to have an IP route, then it will stream directly from the camera. If not, so say I'm trying to watch something in our London location, then it will send it through the cloud. This is dynamic, so if I walk into the office and connect to the Wi-Fi, it will switch from cellular back to the direct route. So what is this thing about better security also making this simpler? So to do this, we need to be able to serve the camera video from both dashboard and from the device itself. And that's tricky because the dashboard is served from dashboard. And that's HTTPS, and we're not going to go put like root signing certificates on people's cameras, because that's a really bad idea. And you don't want to have mixed mode content, because no browser will display it these days. So what we need to do is we buy a certificate for every camera from a global CA, from DigiCert. So every camera has its own wildcard cert, which it can sign its own subdomains of. And so every camera is actually signing its own pages that it delivers to you. And we manage the life cycle of that certificate for you. You have no self-signed certs. You don't need to install your own cert authority because it's a global CA, so trusted by every browser. It's one of those rare instances where like the best form of security also makes the simplest user experience, which is, to me, really cool.
How does the local video access know if I'm local?
It just tries to set up an IP connection to your camera. And if it can't, then it will go through the cloud. What that means is you can end up in a nasty situation should you have like a internal network infrastructure which prevents that. So say you have camera on one VLAN and you're requesting client on another VLAN and you don't have a layer 3 route between those VLANs, the camera's like, oh, better send it through the cloud. And so for the security guard who doesn't know anything about VLANs, it still works. They keep using it, but you're tromboning your traffic out to the cloud and then back in. So you're using upstream and downstream, and you may not know it. The user knows it, they're shown it in the interface, but you as an IT team would be like, what's going on with this network traffic? This is a bit weird. So that's one of the things to be cautious of, is we're automatically trying to find the connectivity for you, and so you could end up consuming bandwidth unnecessarily if there isn't a route between the devices.
So these devices are storing the video on the camera.
Correct.
Are they replicating this video to the cloud as well?
They are not, no.
Okay, so bad guy comes in, destroys camera, steals stuff, no evidence.
We're going to go through that, but a couple of points. We find that it doesn't happen very often. We've actually had more customers have their NVRs stolen or they fail than we've had cameras destroyed.
Yep, that's fair.
The other thing is you lose everything if your NVR goes. Well, if you lose the camera, you just lose the camera. The NV72 that we had here, this is IK10 plus rated, so you could take a baseball bat to it. Super vandal resistant. I normally bring one around with me so people can wail on it. It's quite fun. So you can sort of mitigate the risk. There are some new things I'm going to talk about that we released at the end of last year, which will give you some more options as well.
Okay, thank you.
Okay. Everyone in the world that I speak to wants analytics. They may not know what that means or what it's going to do for them, but they say they must have analytics. So
true.
so you've got to like do the analytics, but we're also about making it useful. Because we have no service, it all has to happen in the camera, which is really hard. I'm going to go through some of the really cool things and the really new things that we've recently released around analytics. But essentially, all the analytics processed at the edge, the metadata is aggregated in the cloud. That means we store a lot of data, like a crazy amount. So we store like over 1 billion video files, and then there's metadata for all the pixels within those. It just becomes like really huge, really fast. Okay, I'm going to do a new product focus. So you're probably wondering why you have a camera in a box that wasn't on my slide. Well, that's because 2 weeks ago, we announced this little thing. Now, what is that? Let me explain. One of the things that I'm always being asked is, but do you have a PTZ? And I can see a beautiful PTZ in front of me here. And for customers, this is a thing that they've thought about or they think is really useful to them. And when we dig into it, the whole idea of PTZ is to move it around. So pan, tilt, zoom. And so why do customers want it? If you abstract, again, about the whole idea of what this thing is for, they want to do more with less. They don't want to buy 4 cameras to look down each leg of this corridor. They want to buy 1. They want it to look over here and over here and over here. They just want less cables. They want to do less installs. They want less switch ports. They want to buy less cameras. They want to do more with less. But there's a problem with the PTZ, which is they only record where their point is. So they're recording over here, and someone breaks in over here. You have nothing. They tend to be less reliable and more prone to failure because you've got mechanical parts. There is a vendor that will remain nameless, but their warranty decreases the more you move their camera, I found on their data sheets, which I thought was like a pretty intriguing thing. The more you move it, the more useful it is. The more useful it is, the less it lasts. It's not like a deal that I'm super excited about. And they tend to be pretty large, clunky, and expensive because you've got to put all that stuff in it. So if we go back to this idea of focusing on solving problems and not building features, we should look at that core problem of seeing more with less in a different way. And the idea was, what if we could capture everything all the time so you don't point it the wrong way? What if we eliminate all the moving parts to make it more reliable? And what if we really shrink it down to make it as small as possible? And that's where we introduce the MV32. So you all have one of these to take home and go play with yourself. You're going to see it in the demo. It is super fun camera to play with. So it's an ultra compact 360-degree camera. It has an Ultra HD 8.4 megapixel sensor. And it does live and retrospective pan tilt zoom digitally because it records everything. And it also officially supports VR with Oculus headsets.
Cool.
This is like every...
It's kind of like that. I don't know, but it's cool. Like,
So,
you said Oculus there.
so you can also do it on a Google Cardboard, and you can do it in Google Daydream, but it's not officially supported because it's not quite as stable because the phones tend to be very, very different. It's hard to support so many different phone platforms. So the official support is for Oculus headsets.
Can I ask what problem you're solving with that?
I was hoping you were.
I was going to ask something similar, but yeah. Well,
I really I was entertained the first time a customer called me on that. They're like, yes, I'm going to be honest. we built this because it was cool. This was definitely not one of those ones that solves problems. But then I was wrong. Because as we started showing customers, I am genuinely surprised at the number of retail customers that are using VR today for real, for business problems. But they're paying specially for it. And so a retailer is telling me we pay a third party to go to a store, VR it, and then we have a collection of VR records for all the store, which the management team use for planning store layouts. So they put on a headset, and they look around the store, and they use that as they plan different changes to these different stores. So they don't have to travel to them all, and it's not just pictures, it's much more immersive. And this is a really intriguing thing because you don't buy this for VR, you buy it because it's a better security camera that happens to also do VR. So you can completely ignore the VR, or you can use it because it's there. And that's very intriguing. I think the other fun thing is every IT person in the world wants to invest in VR, but they have IT budget for other things. But now they can spend their IT budget on security cameras and get VR for free. So it's like a nice additional thing. So it's a really, really small camera. It's quite a marvel to make something so small. I'll talk a little bit about that in a few slides' time. But we're now going to focus on wireless. So this camera, that camera, the MV12 you have in there, in fact, all the cameras we now make, they support wireless. So there is wireless in all of these cameras. And we're going to go through how and why and what the purpose of it is over the next few slides. The main use case is this. You have an analog camera deployment, and you want to upgrade, but the cost of recabling is more than the camera. And this happens time and time again. You have all this coax cabling in the wall. Replacing it costs money, it's time, it's disruption, but now you need switch ports as well. So you now have to buy all these switch ports to plug in your cameras. So the main use case here is to allow people to upgrade their analog camera systems to a modern NV Smart camera system without a ton of extra work. But they will need to have wireless to make it work. The other use case is for customers that just have real limitations in where they can deploy things. So we're seeing customers deploy the MV72 as a manufacturing use case. A customer was showing me in Europe earlier this year their cement factory, because they could put an MV72 out there and it worked wirelessly. They got about 30 meters connection because there was no way they could put fiber or copper to it. And now they watch the cement mixers come into their factory. So enabling new types of use cases where the flexibility of the deployment is really important. So a little bit of backstory on this, because it's not just about wireless. I'm going to explain what the sort of Nest thermostat / mini Roomba / whatever you want to call it, hockey puck thing is on the tables that I've given you as we go along. But for an analog camera system, you need a few things. You need your camera, and you need your DVR, your digital video recorder, but you need power for the cameras, and you need to get the data from the cameras. And the power is typically 12-volt DC or 24-volt AC. And then you have the beautiful coax connecting your camera's data plane. IP-based, simple enough. You have an Ethernet switch, does PoE, and then you have Ethernet for the cabling. So the wireless on the camera. That slide will become obvious in a minute for why I've sort of teed up the next thing. The cameras all are 1x1, dual band, 2.4 and 5 gig, 82.11 AC wireless clients. Now, why is there a picture up here of like a small patch antenna inside the camera? It's really, really hard to make a good wireless camera. The reason it's really hard is, if I just give you that camera here, does that have like a good weight to it? Or do you think it's quite light, quite heavy?
It's quite light.
It's quite light? But for its size?
For its size, it has a great weight.
It has a good, thank you. Right.
Suck up, man.
Like you're prompted.
You read me
Walking
perfectly
into a
there.
trap either way.
So the challenge is, yes, it contains very powerful mobile silicon that we have in our phones and all that stuff. But your mobile phone sprints. It doesn't run all day. And so, although we have no battery, heat management is one of the big things we need to think about when building something that's really small and really powerful. And so the weight in this is actually because it has a huge die-cast exoskeleton inside it, which is all around the PCB. So it's plastic, but all inside this is a special type of aluminium that covers everything. And that's what keeps the camera running cool when it's running all of the time, full power to do all the cool stuff I'm going to show you. The problem with that is where do you fit the wireless antennas? Because metal is not good for Wi-Fi. So we have to sort of like carve out these little gaps. You can see this is like the bottom part of the metal sort of skeleton piece here in the side so that the Wi-Fi can work, and it has 2 antennas inside it which it can pick from. What's even more interesting is the outdoor camera from a wireless perspective. Why do you think that's like even more interesting?
Generally, sorry.
Go ahead.
Well, generally you're not providing, you're not intentionally providing Wi-Fi coverage in places that your cameras are going to be. You're generally trying to provide Wi-Fi coverage at 4 feet off the ground, not 12 or 15 or 20 feet off the ground. Right?
Yep, that's a good one. Any other sort of...
It wasn't good enough, though.
Apparently, yeah.
I mean, it's a really good one, but it's not the one I was after, so I'm going to have to keep going.
Sorry.
More efficient antenna used to get back into the building or back to where it needs to go.
Yeah, that's often an issue. The main one I'm going for is the whole thing is metal, and the only thing that's plastic has to be transparent, so the camera can see out of it. That is really, really hard, especially if you want it to meet these like super high levels of vandal rating. And so what's pretty magical is on the outdoor camera, it has this plastic shield here, and they've hidden the antenna inside this. They're actually stuck to the inside of this. So it's inside the optical dome, but it's not in the way of the camera because it moves as you set the camera up. And the rest of it is all metal, so it provides the impact rating. So it's pretty hard to make one. The good thing is we know a huge amount about wireless. I am pretty certain we're the only vendor that publishes your sort of propagation diagrams for cameras. I've never seen that from anyone else. And so the wireless on the camera is pretty awesome. The way it works is you configure a primary and a backup SSID. The backup SSID is mandatory. The reason, and that can be anything. It could be just like another SSID you have configured. The problem is if you disconnect the camera from the network, for whatever reason, you need to plug it into something to get it back. So having a backup SSID that you can use to recover it is really important to prevent you getting on a ladder and trying to pull it down. Today, you have to pre-stage your camera to make the wireless work. So it needs to be connected to an Ethernet port to get the config before you can put it up there. Sort of like a chicken and egg situation. Cloud needs to send its config. If it can't do that, then it's not going to get its wireless config.
But if you're migrating your wireless around, you can take advantage of the primary and backup.
So we actually allow 3, a primary, secondary, and a backup, but it's mandatory to configure a primary and a backup.
Okay, so if you're switching your whole thing around, you can put the new one on as a second one or a third one, and then retire your first one and reorder them.
And the really cool thing to do is you can put the backup as the hotspot on your phone.
Yeah.
Oh, nice.
Yeah.
Okay.
And I'm going to explain some of the fun stuff you can do with that. And it works with any standards-based AP, not just a Meraki AP. So whatever AP you have should be a Meraki one, but it will work.
You're not expecting client access on that. It's all, you're just...
This is purely as an uplink for the camera. It's not providing any type of access to the client. So what is the thing that you have in front of you? Well, really cool. If you remember back to my slide with the power, and like why are we learning about power? Well, you need to get power to the camera. It's all very well saying, we want a wireless camera. Many customers said, we want a wireless camera. And then you said, how do you power it? And they had no answer. Is this. This is a special type of power injector. It's a low voltage power injector that takes 12 volt DC or 24 volt AC, and it converts it to PoE with a budget of, annoyingly, 23 watts. So it's not PoE plus, but it's more than PoE. And it's pretty magical. Auto voltage sensing, auto polarity, you screw in the wires and it works. We sent these to some beta customers, they screw in the wires and it works, and we asked them what voltage they put in and they don't know. So don't put in 110, it does not work with 110, but it definitely works with 12 and 24.
It'll work for just a second.
Yeah, very briefly.
So you've got your analog camera, you've got your 12 volt power, that comes in on this like, often you get this twin cable here, or it could be a separate 2-wire cable going in, and that goes into the screw terminals. So if you have one of these, put your thumb in the hole, wrench until you think it's going to break, and it'll open nicely. You have to pull it really hard, like really hard.
Fine. You do? Yeah. There you go.
It's really strong. You can do that many times and it's fine. It does have a serial number on it, but you can't add it to dashboard. That's just like a mean trick. It's not something you can manage from dashboard, so please don't try and add the serial number to your Meraki dashboard. And that gives you PoE out. So the data goes wirelessly, you leave the coax in the wall, you can chop it out, leave it there, do whatever you want with it. There's no need for cabling.
Just a quick question going back for a second.
Yeah.
If you're planning on running this thing entirely wired and not using the wireless functionality, you could just leave all that alone. You don't need the SSIDs at all? Or
you don't need them at all.
Okay.
Don't need them at all.
Cool, thank you.
A lot of people think, oh, so it's wireless or Ethernet. No, you can use whatever you want. You can even have it sort of fail from one to the other, but it doesn't make a lot of sense to power it from a real Ethernet switch and then make it wireless. Sure. We do that for testing, but I feel it'd be quite strange for a customer to supply it like that.
So as somebody who's done some camera deployments, and I got to say, this is slick. This is really slick.
So do you know why we made one? Because no one else makes a good one.
Right, yeah.
And no one makes a good one because there aren't good wireless cameras. So we're like, we don't want to make small accessories. I'm going to be honest, it's a lot of work and we want to make cameras. But to be able to do this and have a really good, simple Meraki proposition for wireless, this was what we had to do. So it's pretty straightforward, but it's also really fun. So this is my colleague Matt. He's on a boat and he has a camera. He also has a 30-watt solar panel that we have unfolded, and the camera is tethered to the hotspot on his phone. And so now our colleague who got rather seasick can watch us drinking beer on a boat in San Francisco, and this is over 4G from his phone with the camera powered from a solar panel. So it's just a PoE thingy. You can power, and we don't recommend this, access points and other things. It's meant for cameras, but you have a car battery, you can power a PoE thingy from it. You have a solar panel, you can power a PoE thingy from it now. This is 100% not officially supported. It is meant for cameras for doing upgrades, but it is one of the more fun little widgets that I have lying around the home, so I hope you have some fun playing with them as well. Any questions on the wireless or the PoE injector?
Maybe other product, other cameras. Do you have any cameras that are able to be daisy chained? You know, so if you're doing, let's say you're going in greenfield, you're putting in just IP cameras. Do you have anything that is capable of, say, so for example, well, there's other products on the market where you can run from the PoE port to camera one, from camera 1 to camera 2, or something along those lines to kind of minimize those?
Yeah, we don't have a PoE out on on the cameras. The one option I can offer you, and I have deployed this, is MR30Hs. I'm not sure if you're familiar with that model of access point. It's designed for sort of like hotel room and hospitality deployment.
Yeah, okay.
As a PoE switch. I did an office deployment where we halved the cable runs because the camera is off the AP.
Yep.
And it comes off the other PoE port.
Makes sense.
So it's the PoE plus port into the access point, PoE out, which is designed for a phone or something else, like a thin terminal device, and we just run the camera off it.
Makes sense. Okay.
That's good.
Okay, we're going to move on to some of the cool analytics that I promised. This is Australia. This is our first generation of cameras, and this is some sheep. And so this is the Department of Primary Industry in Australia, and they were using our first generation of cameras to understand sheep grazing behavior and using the motion analytics in our heat map function to understand whether sheep had been grazing at a given time. Now, what's interesting to me about this is I do not want to watch sheep in a field, nor do many other people. The camera doesn't really care, and it can do it all day without getting bored. But the value is not the video. The value is actually the analytics outputs. And so the camera is becoming like this sensor. When we talked about information earlier, we talked about people thinking about cameras for information. That's sort of what sensors do. So if I think about cameras as a sensor, I really love this particular idea because it seems so contradictory as a product manager for cameras is, what if we never show you video? Well, if I make a video camera where the whole aim is to never show you video, if we take that as a concept and sort of try and like play it out, we can end up with some really intriguing new functionality. And so one of those is a complete rework of our motion search engine. So Hopefully some of you have seen the demo on our previous occasion, or you've seen it online, but it allows you to search for things that changed. Well, we completely rebuilt this using the new powerful hardware and all of these cameras that we've talked about today. It's Motion Search 2.0, and it uses a new powerful algorithm called, which works using background subtraction. And we're going to talk about how that sort of does its thing, but it has increased fidelity for small changes, doesn't get as many false positives, works much better at night because it's not reliant on color in the way that our previous algorithm was, and it allows us to do some really cool stuff like this. This is motion recap. So this idea of trying to convey everything that happens in video without watching video is really powerful. And motion recap are composite images built in camera with no servers that summarize all activity in a video in one frame, so you can find the answer without watching the video. So in this example here, we have this woman walking through our office. You can see she's holding a glass, and she's like walking along, and she's reached over this counter, and I know there's like a water container over here, and now she's filled up her glass, she's having a sip, and she's walking off. This is like a 30 or 40-second event where I no longer watch video. In fact, I find it more useful than video because it contains all time context simultaneously. I'm not fast forwarding and rewinding and messing around. I see everything all at once. This is our resale store in San Jose, and you can see where people are going and moving around and like using things all in one image. Again, this is with no servers, it's all done in camera, and this is going to be a software update to all our cameras at no cost to our customers.
Okay, so how hot does the camera get now? Because you're talking about some really cool stuff that's done in camera.
Yeah.
It's a lot of processing.
It gets pretty warm. You will definitely hold it and be like, that's a warm camera. But it's designed to do that. That's why it's quite heavy, because of all the heat dissipation in it. But it's one of the things that we do have to actively manage, as in like, we build a thing, we looked at it. Firstly, when you first build something like this, it won't actually work on the camera. It'll only work on like your laptop or a desktop. You spend a lot of time optimizing it. It'll work on the camera. Then the camera is like too warm. If it gets really warm, it throttles its CPU usage, so then it doesn't actually run fast enough. So you can't then work it too hard. So then you optimize again, and you optimize again, and then you get to stuff like this. So ever wondered how your parcel end up smashed to pieces? Well, you can see it flying through the air towards my colleague's front door, and then slamming into the door. This is Klaus. This is a fish in our office, in a fish tank. This camera is actually in the fish tank with the fish. This is the MV72. It's been there for about a month now. It's only IP67 rated, so that's a meter for 30 minutes, but it's been about half a meter for a month now. It's running along nicely. So you can watch these motion recaps of the fish. You can see some other ones, such as this is like the Meraki balcony, sort of like the holy colored chalk celebrations. This is a skunk that my colleague discovered in his garden. Like those small fidelity changes, like you can really go back and find out if there was a skunk in your garden, which you didn't know about. This is a nighttime shot where it's managed to catch this cat. My colleague had a friend come over. They fell asleep on the sofa with the remote for the garage in, opened it, and he wanted to know if anyone had stolen anything overnight. No one had, but you've got this neighbor's cat coming into his garage. You can get attacked by butterflies. This is just one butterfly that's just like completely freaked out the camera. And then you can find out what your dog's doing. Or you can get super freaked out at Halloween and get up in your front door. Looking like holding a baseball bat. I mean, I'm not really sure what's going on there.
They want to test the camera.
Yeah. Okay, so when I think about this from a user perspective, you know, maybe the first use case that comes to mind is, you know, something happened in this particular area, but in this 12-hour period, right? Yeah. And so now what I'm looking for is here's a spot in the camera's coverage. I want to see everyone that entered this area. Is that the type of searching that can happen right now?
We're going to do all of this in the demo. Because like, this is cool, but I feel like you may not believe that it's true, even though I've given you the thing. So you're definitely going to find out within like a week or so, because you'll get hands-on. But we're going to show you in the demo in one slide time. Thank you very much. Wow, that was pretty... yeah, your payment will be coming later. So let's open up this. So this is the Meraki dashboard, which hopefully you have all seen by now. You can go in and look at all your things. Cameras are now one of the things you can look at. It doesn't seem like a big deal, apart from no one else makes mobile device management and cameras together. And when you think, like, what's the point of that? Well, when you set up geofencing on Systems Manager, you can get alerts when someone leaves the building. And then you're like, what's the first thing I want to do when I know someone's iPad's left the building? I go check the cameras at the front of the building. So it makes it very easy to sort of look at these type of use cases which were previously completely separate systems. So we've got our cameras in here, and I could go and say, let's look at the ones in our bike room. And now I'm going to go down to these one here. And so what you're seeing, this little spinner here, is because I don't have an IP route to this camera. It's built a cloud connection for me. This is why I've got this little cloud symbol. And so now we are looking at the camera remotely in San Francisco from here. And I could go click on the timeline. It will go to the camera, and it will go ask for the video. And then it will start streaming the video back to me if I want historic video. Nothing super exciting so far. What I could do is I could also use natural language and relative time. So I could say yesterday noon, for example. And it will go back and ask for yesterday noon. Or I could say last Friday 2 p.m. I'll go back and find the video from last Friday at 2 p.m. So this bike has now like appeared. And like, OK, what happened to that bike? So this is where we can search. So I can up here and say search. And now we've got the grid overlay. We keep metadata for every one of these squares for every camera all the time. And now we can go search for anything retrospectively. You can go in here, and I could say, search this bike. It's going to come down here. OK, nothing's happened. So I'm going to zoom out on my timeline, and it's going to research. And now we have some events. So we can go and say, huh, maybe this is the guy I want to go check out. And now we're going to watch the video. And we can speed up, because otherwise it's going to take a little while. So there we go. So in just a few seconds, we can go find the video of the guy taking his bike, and then we could export this. So I could say, OK, I want to export this, because it's on the camera right now. I want it forever, or I want to send it to the police. You can export this, drag my sliders. It'll take it from the camera. We'll save it in the cloud. It gets timestamped and watermarked. We keep it for a year. And you get a SHA-256 hash, so that should you give it to the police and you want to prove it was never tampered, you've got that for a year to prove the sort of chain of custody for it. Maybe I want to just...
So in that case, they're getting a link from the cloud that they're going to access directly from
And the great thing about that is then they don't touch the camera. So should lots of people need that footage, they're not constantly going back and asking the camera or going through your network. It's just updated once. I could take a screenshot. So I could say, OK, here's my screenshot.
How can I truly export the video?
What do you mean by truly export?
Save it local.
I want it off the cloud. I need it more than a year. If it's a murder case, it's going to be longer than a year.
Well, you just download it, and it's up to you to then keep it.
Oh, so you can truly download it?
Oh, yeah, you can truly download it. It's a H.264 encoded MP4. You can play it on anything. You don't need a special thing to play it. The file is yours at that point. Okay. We keep it for a year just to make your life easy. You could burn it to a DVD, which is probably what most people would do in a court case.
What about on the camera retention? How long is that 256 gigs going to keep me?
Good question. So if we go up here to where it says settings and go quality and retention, we can configure how long this camera will store for. This one is currently configured to store for 7 days. We could change some of the quality settings. So we could say, OK, I want...
that's high quality for 7 days then, right?
That's maximum everything.
Yeah.
So we could sort of change the bit rate down a bit, frame rate down a bit. But the main one is this thing up here. I'm going to just move that back up to maximum everything, called motion-based retention. So the industry standard is something called motion-based recording. You have a memory buffer. You're always recording into like a 20-second, 30-second memory buffer. The camera sees something happening, and it's like, write it to disk, and starts writing it to disk. Problem is, if that thing doesn't trigger the camera, then you don't get it. So we had an example which helped us really think about this in a different way from a customer that had a sprinkler system activate overnight, flood the office, and they had no video the next day to know at what point in time that happened, because the water droplets are too small at night to trigger the recording. So we do something different. We do motion-based retention. So we keep all video, and we write all video to disk. Then after 3 days, we go back and we remove any footage of that activity. So what that means is you're guaranteed to get a 3-day buffer, and we can now predict across a global set of cameras based on averages for all those cameras how long you will get at different settings. And we can do it for this one unique camera. So I can come in here and I say, turn this on. And what it's going to do is going to go and look at the last week of data and predict how long you're going to get based on that. So you can uniquely optimize this camera. Maybe I want more than 46. I can go enhance. Now we're more than 90 days storage on this camera.
Clever.
Now, if we go back to our video here, so we've got this guy. He's going to, I'm assuming, leave the office shortly here. There we go. And we keep context across the set of cameras in my query, because I search for bike. So you see it says 11 cameras up here. And now I watch this, we can see the guy leaving. Or we can scroll back, and then we can go back inside. So even though these cameras are separate, they're not like talking to a server, we're sort of being able to use them as a set.
How does the show people button differ to the motion search?
Oh, we're going to get onto that.
Okay.
There's a lot of cool stuff. I'm going to try and pack it in super fast. So if you want to see lots of cameras, you can do that. So you can tile up to, I think we're now at 16 cameras per tab. You can have as many tabs as your browser and your computer can survive. Should you want to make a new one, I could say edit layouts, new layout, and then we can go, okay, a new one here, and say I want to add this camera, that camera, this camera, that camera, and then I can just dynamically resize it and sort of create whatever type of layout I want, and it's all in browser. All right. Now, I talked about motion recap, and now I want to show you some super cool motion recaps, which are going to be on the NV32 in San Jose. So this is the Cisco corporate retail store in San Jose, and we're going to go motion search. I'm going to come in here, I'm going to search the store here, and now we get to see all of these events. So like this person moving this box around, you've got the staff member over here walking here, you've got this like customer walking and now looking at these different products. And so if we want to go look at those, I can click on this, hit play video, and it's going to go and launch the video so we can then watch that particular moment. So motion search just drastically reduces how much time it takes. So you see, like, now we're watching this person is like taking all this time. But the cool thing now is I can pause this and I can go de-warp, and then we can de-warp it and watch it and look around.
What the what?
So don't pick your nose near a Meraki camera. Like these are.
And then we can like zoom in, like, okay, what's he doing over here? Oh, he is picking his nose.
Oh, there he is.
Oh, that was no.
We timed that earlier. It was set up.
And so I could look around. Is there anyone else in the store? Nope. I could look around here, and he's still kicking some more boxes along. And then should I have a VR headset plugged in, or if I have a VR-compatible phone, I pick VR, and I go into an immersive VR world, where I am basically stood on the ceiling in San Jose looking at everyone and all the stuff in the San Jose retail.
Which of these boxes had the VR headset in?
I'm afraid it's BYO VR.
Yeah.
Type of thing.
So when you do enter that VR mode, and you were talking earlier about the retail environment, setting up stores, are these retailers able to kind of walk through the store with a headset on, or is it just
No,
a
it's
static
not
view?
that immersive.
Okay.
It's like you are in that sphere, essentially, that the camera has captured. So what we do is we take the circle and then we project it on the inside of a sphere and then de-warp the optical component of it so that you're stood in it and you can look around. If you want to zoom in, you like move your head like this and you like zoom into the product or whatever it is, but it's not that immersive just yet.
Okay.
We built it for fun. Turns out people actually want it for lots of stuff now, so maybe we'll relook at putting some more engineering work into it. Okay, now we're just going to switch back to my slides here because we're starting to run low on time, unfortunately. So with this idea of focusing on solving problems, lots of customers ask us for APIs. So why do the customers want APIs? Well, it falls into three main categories as far as I see it. They want to integrate their cameras with something else. Things like access control is a really big one. Electronic point of sale. We have a record of someone buying something and we want to make sure it really was a can of Coke and not a bottle of whiskey. The camera helps tell us that. They want to offload video to something else. and they want more analytics because they're told analytics are good and they need more. So how do we meet all of these needs? Well, we have a really cool set of imaging APIs. So these are REST-based APIs where you can pull frames from the camera live or historically. And I'm going to talk about what you can do with those as like a means to do some really cool stuff a little later on. But basically, should you want to have an access control event with a thumbnail of what happened, you can pull the frame from the camera via REST. We now have NV Cloud Archive. I'll talk about that on the next slide. And then the final one, and the one that is the most exciting, is NV Sense. So what is NV Cloud Archive? Well, the base thing is everyone buys a camera that stores video in the camera. But some customers want to store longer than you could ever store in a camera. They want to store 24/7, or they're worried about their building burning down or something terrible happening. So there's now an optional software license to store 90 or 180 days, 24/7 in the cloud, and the camera dual records, so it has both local and cloud-based footage, and it will serve it from the local client if the camera is available, because it's more efficient. And if it's not, it'll serve it to you from the cloud. And it's compatible with every camera we've made, even the very first one. You can buy this in 1, 3, and 5-year increments with 90 or 180 rolling days on your camera, and you can have it on one camera, some of the cameras, or all of the cameras. It's unbelievably easy to set up. You just add the license, and it works. And we've done this in partnership with Microsoft Azure, so all your data is stored in Azure.
What's the bandwidth utilization?
1 meg per second upstream. OK. So the smart camera concept is all powered by the next generation, essentially, of smartphone silicon. Ours is based on a Qualcomm Snapdragon system on a chip. And this allows us to do machine learning-based computer vision. So computer vision inference, it's done in camera with no servers, in real time. And it can do object detection, classification, and tracking. I'm going to go through some of that in a second, but I'm just going to give you a quick demo. Because someone asked about people. I'm going to type staircase in here. We go analytics. And we have like the heat maps that you saw earlier. But on a staircase, there's a lot of people. So you've got a lot of heat. It's not really providing a lot of information for you right there. But up the top here, this is a graph of people that the camera has seen throughout the day based on machine learning detection of people that happens in real time on the camera. So if I go, I'm going to go pick, say, Wednesday last week, for example, and we have a whole day. We can see the flow of people throughout the day. We can drill down, and we can go into a single hour. We can go into a single minute. I'm just going to pause to let the video catch up with the overlay. But what's going to happen is it's going to play back all the metadata relating to the detections for the people in the video. There we go. And all of these were done in the camera. So people detection is not revolutionary, but doing it with no servers really is. Because anyone can buy a camera. In fact, you will have this in your cameras. You can use it at home. I'm going to talk to you about how you can use the APIs to make your smart home super smart. So you, like my colleagues, can build connections to your light bulbs or to other things in your home and control them via camera. So all of this is just done in the camera.
Now, these are all completely independent of any other Meraki infrastructure. So
absolutely.
If you just want the cameras, you're good.
Yep, and we actually have customers that only are camera customers. So the reason this is important is you don't need a hulking big server full of GPUs. Because although this is cool, it means you can't easily go and deploy it everywhere. But if you have a tiny camera, and this is the PCB for the camera, this is like all the magic is this. All the rest is just to make PoE work, because no one's miniaturized that. That is what helps you go and do this type of thing. And so this is the final piece, where we're going to focus on this API. So you've got this need for analytics. You've got all the video coming into the computer vision algorithms on the camera, and you want to build your own thing. How do you build it? How do you build it really easily? Well, we have two sets of REST APIs. An aggregate one, where you can say how many people were here in this zone or these locations any time up to 12 months after the video was captured, even if the video doesn't exist anymore, and we'll tell you. If you want to know how many people are in the room right now, or in that checkout line right now, you can ask us. We ask the camera, and we return the result to you. Again, a REST API. And the last one, and the most exciting one, is the real-time one. This is where the camera interface enables MQTT. So if you're not familiar with MQTT, it's a really lightweight messaging protocol for sensors. So the camera is treated like a natural sensor, and it gives you all the coordinate data for all the people in real time. And you can also now get other things. So you can now get the real-time light levels from the camera. So one of my colleagues was saying they now have the LifeX connected Wi-Fi light bulbs in their house turn on and off based off the light levels derived from the analytics on the camera. And this means you can take the camera, treat it like a sensor, and integrate it into sets of platforms such as Kinetic, AWS Kinesis, Azure IoT Hub. Anything that deals with sensors, you can just connect the camera to. So the point is, this is not a Connect or some other person tracking things specifically. This is just a normal security camera that does this as well. And it can do location of people with great precision and great speed, which you can integrate into other things. So I'm just going to skip to the very last thing, because I did promise that you could do some cool stuff with that imaging API. So the last demo here, I'm just going to end this. If you know someone's in front of the camera, you can then choose when to pull a frame from the camera, and then you can send that to other machine learning algorithms. And this is where you create hybrid ML, where you do edge-based real-time ML and cloud-based more detailed. And you can then integrate it into our favorite Cisco collaboration tools. So here we have WebEx Teams, and I'm going to search for FedEx. And I'm going to go to my messages. And here we have my bots. And this bot has continuous updates, which are a blend of AWS recognition and camera data. So the camera sees something, it sees a person, it takes a frame, sends the frame to AWS, AWS recognition, does all of these other categories on it. In this case, it read FedEx off the side of the truck, and then sends it to WebEx, where I can then search it as a message. And what's super cool is if you go here, it doesn't say FedEx anymore, and it doesn't say FedEx anymore down here. So it's allowing you to interact with all of this data incredibly simply and build it into your own systems. And with hybrid ML, you can take all of this stuff that everyone thinks is really awesome, and you can use it today. And you can use it today without lots of bandwidth, because you're not putting video into the cloud. That's pretty much it, and I want to make sure that sort of the end allows for any questions. I just want to point out that this is being used today in production by our customers. So the Miami-Dade Library County system are using it today, and they're using it to understand how people look at, take items out versus people that come to the libraries. That's camera and Wi-Fi based. And we also have this partner company over here that's created dashboards that combine camera data with Wi-Fi data, and then they also do demographic data based off the snapshots triggered by the other parts of the camera detection. So this is the demographic data pulled from those cameras. And so the very last slide is you can go hack this all together yourself, or you can buy it from someone else. If you go to meraki.com/marketplace, there are solutions you can pick up. And if you want sample code, if you want the API definitions, if you want to build those interactions with your own light bulbs, meraki.com/developers.